Hi. So here we have let a, b and c be non-zero real numbers such that b square is less than 4ac. Now a very familiar term, b square is less than 4ac. So we'll come back to this. Let's read the question first. And f of x is ax square plus bx plus c, a very standard quadratic function, ax square plus bx plus c. Now if the set S consists of all the integers m such that f of m is less than 0, as in the value of this quadratic should be less than 0, m for all values of m, this should be less than 0, S consists of all values of m for which this is less than 0, then the set S must necessarily be which of these four options. Now let's start with this quadratic function. F of x is given as ax square plus bx plus c. Let's look at the discriminant. Since we want the function to be less than 0, let's look at the discriminant here. The nature of the function is always determined by the discriminant of the quadratic function, right? Whether the function will have two roots or equal roots or no roots, whatever it is, it's determined by the determinant, right? Determinant we know is coefficient of x whole square minus 4 times of coefficient of x square into the constant term. So the discriminant here is b square minus 4ac. b square minus 4ac. Now if b square is less than 4ac, if we take 4ac on the left side, we have b square minus 4ac, which is less than 0. So the discriminant of this quadratic comes out to be less than 0. Okay. Now if the discriminant is less than 0, let's revise how does discriminant determine the value of the function. So now we know the graph of a quadratic is a parabola. It can be either an upward facing parabola or a downward facing parabola. It is an upward facing parabola if the coefficient of x square is positive, and it's a downward facing parabola if the coefficient of x square is negative. So I hope you have seen these graphs earlier. If a is less than 0, this should be a greater than 0. If a is greater than 0, the parabola is upward facing, and if a is less than 0, the parabola is downward facing. And now comes the role of discriminant. If d is greater than 0, the parabola or the quadratic will have two different roots, real different roots. If d is equal to 0, the parabola will have equal real roots, and if d is less than 0, there will be no real roots. And these will be the cases when a is less than 0. Now since we are given that the discriminant is less than 0, we effectively get two cases. One is this and the other is this. So if d is less than 0, the graph or the parabola will be either completely above the x-axis or completely below the x-axis. Okay. So we have two cases effectively here now. First case is that the coefficient of x square, which is a, is greater than 0. If a is greater than 0, then this is the first case. This is the first case. Fx is always less than 0. So first case is when fx is less than 0. This is possible when a is less than 0, right? Now if this is the case, what are the values of m for which the function is always less than 0? Well, the function is actually always less than 0, right? The function is always less than 0 for any value of, you take any value of x, the function is always less than 0. For all values of m, the function will always be less than 0. So from here we'll say S is the set of all integers. For all integral values, this function will always be less than 0. So set S consists of all integers if this is the case. Now in the second case, if the function is always greater than 0, right, when this is possible when a is greater than 0. So now what are the values of m or what are the values of x for which the function is less than 0? Will you get any value of x for which this is less than 0? No, it is always greater than 0, right? There is no integral value of m for which the value of function is negative. The function is always in the positive territory, right? This function is always positive. So here S will be an empty set. There are no values of m for which this function is negative. So here you get S will be an empty set. So either S will consist of all integers or S will be an empty set. These are the two possibilities for S. Hence the correct answer here is option C. Either the set S is empty set, or set S consists of all the integers. This is the place where set M can take any value, M can take any integral value, and here M is an empty set. M, there is no value of M for which the function is less than 0 here. So option C is the right answer here.